Problem 3.26. In this problem, a Burden type pressure gauge is used to measure the pressure from the pitot tube attached to the leading edge of an airplane wing. The gauge is calibrated to read miles per hour at a standard sea level condition rather than psi. If the airspeed meter indicates 150 miles per hour when flying at an altitude of 10,000 feet, what is the true speed? Okay, so in this problem, we basically have a wing. In this point, the pitot tube is attached at this leading edge, and we have information at a point far away. So we're going to label them as 1 and 2. Right, so we know that the value, so for this 2 points, so we're going to just make a small table for point 1 or for point 2. And we're going to write what information we have. We have pressure, velocity, and elevation. We know that at point 1, it's far away. We're going to assume atmospheric pressure. Therefore, our gauge value is going to be 0. The value of the pressure at point 2, we do not know. We do not know the velocity at point 1. However, we know that at point 2, because it's an stagnation point, the velocity is going to be 0. And the only thing that we know about this elevation, since we assume that it's a horizontal streamline, that they're going to be the same. So now let's write the Bernoulli equation relating those 2 points. So we have P1 plus gamma Z1 plus 1/2 rho V1 squared is equal to P2 plus gamma C2 plus 1/2 rho V2 squared. And we cancel the information that we have. So now we know P1, we already said that is 0. We know that V2 is equal to 0. And because the elevations are the same, these two are going to be 0. So we find that the value of the pressure at point 2 is equal to 1/2 rho V1 squared. We know that the meter is reading 150 and is calibrated to be for standard sea level conditions. At sea level conditions, the value of air becomes 0.00238 slug per feet cubed. And the velocity is given at that point to be 150 miles per hour. So to calculate the value of P2 that we have 1/2 0.00238 slugs per feet cubed. And then we have the value of the velocity, 150 miles per hour. And then we do the conversion. So we start with 1 hour is equal to 3,600 seconds. We also know that 1 mile is equal to 5,280 feet. And we have this value square based on the equation. So we find that the value of the pressure is equal to 57.6 psi. So that's the actual value of the pressure. Now we're going to set it back so that we could find that what is the conditions at that particular altitude. So at that altitude, we are going to find, so at that altitude of 10,000 feet, we find that the value of the density is equal now to 0.001756 slugs per feet cubed. So what is going to happen now is that we are going to substitute the value of the density into this equation, and then we're going to solve for the velocity now. So we take the value of the pressure, so it's 57.6 psi, then we have 1/2, the density is 0.001756 slugs per feet cubed, and then we're gonna solve for the value of the velocity at that point square, right? And then if we find the value of the velocity, that velocity is 1, the actual velocity that we're looking for, v1. And we solve for v1. We find that the value of the velocity is actually 256 feet per second, which in miles per hour is equal to 175 miles per hour. So even though the meter indicates that it's 150, because it's calibrated for this particular density, in reality, because the density is significantly lower, the velocity is actually higher than what the meter reads.